H from the homework. I didn't get to cover that in class, so this is a bonus example here for you. Let's look at it here. So here's our polynomial. There's its graph. Looks like it's got a root at x equal 1. And you can zoom out and zoom around a little bit, but I don't think you're going to find any more roots. I think that's it as far as the roots are concerned. So it just looks like we got that one root. Now, according to the degree of our polynomial, the degree is 5. We know there's a total of 5 roots, so we're going to have to account for all 5 of those roots somehow. But it says use the graph as a hint. So let's take a look at this and see, is there some kind of a hint that we can get by looking at the graph? Well, yeah. I guess the first thing we'll get, the first hint that we get, is that there's a root at x equal 1. But there's an important question. You shouldn't just say, all right, x equal 1. Let's look at the behavior of the function at that root. Now, I've tried to exaggerate it a little bit here to make it a little bit clear. There's 3 choices we have for the behavior: bounce, wiggle, or straight through. Which one is this? Is that a bounce? Is that a wiggle? Is that straight through?
I guess we call it a bounce.
If it's a bounce, then it would stay on the same side of the x-axis, right? So either they both be below the x-axis or both be above the x-axis. So a bounce is going to look like this. Like that.
Oh.
That's a bounce. Or that's a bounce. Now, bounce you typically associate with an even degree. So it's not a bounce. Another possibility is straight through. And if it goes straight through, that's fine. It's just going to cross like that. It's not going to hesitate at all. That's a straight through. So you've got a bounce. Bounce is associated with an even degree. Typically you use the smallest degree possible. So n equals 2, 4, 6, etc. Whatever is warranted, but unless there's some extra information, choose x equal 2. Straight through, that's a degree 1. And then last but not least is the wiggle through. And the wiggle through doesn't just slice right through the x-axis unhesitatingly. It kind of thinks about it as, well, I'll get close here. And the important thing is that it changes sides, right? You go from negative to positive, and in between it kind of goes like this. Notice that it changed its shape. It was concave down here, it's concave up here. So that's going to be characteristic of a wiggle. So our behavior here is a wiggle, and that's important because it tells us something about the multiplicity of 1 as a root. What multiplicity do we get here?
If it's a wiggle, then it has to be n equals 3.
Yeah, it has to be n equals 3. Thank you. So as far as this polynomial is concerned, we know where 3 of its roots are. Now let's write down this polynomial, and we're going to divide out this x minus 1 term. We're going to have a total of 3 factors of x minus 1. And I want to divide all of those out of this. So this is going to take a while. So let's see. We've got this we're going to do by synthetic division. So I'm going to write a 1, negative 3, 19, negative 49, 48, and negative 16. Since we're doing this by synthetic division, I'm going to leave a little space here for me to write in. Draw a nice long line. And then I've got this little tail here at the end. What's this part at the end for? This vertical bar down here.
The remainder.
The remainder. Now because 1 is a root and this is a factor, we should get a remainder of 0. Let's put in a 1 here, corresponding to what makes this equal to 0, or the 1 there. Another thing we're going to put in is a 0 here for our first number. Now you add to go down, so it's going to be a 1. Multiply to go up, that's a 1. Add to go down is negative 2. Multiply to go up, still negative 2. Add to go down, 17. multiply to go up, add to go down, gives us negative 32, multiply to go up, still negative 32, add, and then multiply, 1 times 16 is 16, and check it out. Nice big goose egg. But we know that that is a 0 3 times in a row. So we're going to keep going. Basically, I'm going to take this reduced polynomial. Basically, I figured out that my polynomial can be written as x minus 1 times x to the 4th minus 2x squared plus 17x. Excuse me, this should be a cube. 17x squared minus 32x plus 16. X equals 1 has to be a factor of this polynomial. So I'm going to use the reduced polynomial and repeat this operation. So the coefficients now are going to be 1, negative 2, 17, negative 32, and 16. Same kind of game as before. We're going to put a 0 underneath this, add going down, multiply to go up. So add going down gives me a 1, 1, negative 1, negative 1, 16, 16, negative 16, and negative 16, and cool. Once again, you get a nice big 0. So now what has that told us? Now we can rewrite this polynomial as p of x equals x minus 1, and then x minus 1 again times x cubed minus x squared plus 16x minus 16. And we're whittling away at this problem. We keep on chipping away at the factors. X equals 1 is a factor one more time, but we're going to work with this reduced polynomial. So now it's just going to be 1 into all these, 1, negative 1, 16, and negative 16. So same thing as before, add going down. We'll put a 0 there to start. So 1, and then 1, 0, 0, 16, 16, and 0. So cool. Overall, let's see what that gives us. What does this polynomial represent at the end? Well, it's x squared plus 16. That's all that's left. If we look at our polynomial p of x can be written as x minus 1 times x minus 1 times x minus 1, which of course we're going to rewrite as x minus 1 cubed times x squared plus 16. So x minus 1 cubed times x squared plus 16. Let's see what we can do with this. I think the problem asks us to find all the zeros. We know where 3 of them are, right? 3 of them are up here at x equal 1. The other possibility is we get zeros from this. So now we need to find out where x squared plus 16 equals 0, which means x squared equals negative 16. If you take plus and minus the square root of both sides, what's the square root of negative 16?
Plus or minus 4i.
Plus or minus 4i. So what you'll have to write in WebAssign when they ask you for the roots would be this. Roots are at 1, 1, 1. That's a pain, but I didn't write WebAssign, so don't take it out on me. 4i and negative 4i. So if it's asking you for all 5 of the roots, there they are. You could also write this in factored form if you wanted to. Factored form, it would look like this. I'd simply take x equal 4i and x equal negative 4i and turn those into factors. So I could write this as x minus 1 cubed, x minus 4i, and x plus 4i. That would be our polynomial turned into a product of linear factors. So you absolutely really need to use the fact that x equal 1 as a root 3 times. So that comes from looking at the multiplicity. And you can see the multiplicity here is a wiggle, so that's going to be a multiplicity of 3. Once you determine these 3 roots, then you might have to use the quadratic formula or factoring or whatever to finish finding the remaining 2 roots. In our case, we get complex roots, which isn't a surprise because we accounted for 3 of them. The 2 that we couldn't see were our complex roots. Any follow-up on that?
So you have to do it twice, like you have to do
We had to do it 3 times. Once for each occurrence of x equal 1 as a root. So I knew it was a root with multiplicity 3.
Oh, okay, so
So I did it, I divided by x minus 1 here, here, and here. Now the thing to keep in mind is you want to use the reduced polynomial each time. So once I divided by x minus 1, I didn't use the whole polynomial, I went and used the reduced part. And once I did the reduced part there, I divided by x minus 1 again, that gave me this term here. So I keep on chipping away at my polynomial, and eventually I get it down to something that has a quadratic. And no matter what this quadratic is, when you set it equal to 0, you can always solve it with at least the quadratic formula. But the trick is to make sure that you keep on using the reduced polynomial each time. Each time you divide out the x minus 1, you write it as a factor and work with the reduced polynomial. So, yeah, makes it pretty easy. All right, good with that one? Anything else?
That was one, yeah.
Good, all right.
Is this tutoring?